Recording in progress.
Hi students, in this lecture I am going to discuss problems based on law of conservation of momentum. Let us see. So first is statement of the law of conservation of momentum. If the net force acting on a system is zero, then its linear momentum is a constant. This is known as law of conservation of momentum. Okay. Let us see now problems based on this. See the first one. A shell is fired from a cannon with a velocity v meter per second at an angle theta with the horizontal direction. At the highest point in its path, it explodes into two pieces of equal mass. One of the pieces retraces its path to the cannon, and the speed of the other piece immediately after the explosion is. So this question is asked in 1986 for 2 marks. Let us see how we start the problem. So first write down the given data. Let's see condition given. It is like oblique projectile. Follows parabolic path. At a highest point, it explodes given at the point of projection. Velocity is v, angle is theta. At the highest point, it explodes. And you can see at the highest point, velocity v cos theta along horizontal. Now this explodes into two equal fragments, right? See how we are solving the problem. If you observe along horizontal, there is no net force. Gravity is only along vertically downwards. There is no force along horizontal direction. That means we can conserve momentum along horizontal. We can conserve momentum along horizontal. So here what we are doing is just before explosion, just after explosion. Okay. So write here equation, that is LCM, law of conservation of momentum. Just before explosion, I am taking here right as a positive x-axis. So it is now m into v cos theta. So this was the momentum before explosion. Now focus just after. See one condition given that one of the fragments retraces its path. Retraces its path means its velocity must be v cos theta and direction must be left side. If it is v cos theta, then it follows now the same path and retraces, okay? Because we are knowing that velocity v cos theta means it covers a distance r by 2, right? So if it is left side, it covers r by 2 by retracing the path. So here I can write m by 2 into minus v cos theta. Plus, for remaining, we have to calculate velocity, right? So m by 2 into, take velocity as v, which we have to calculate. Now, simplify this. Mass cancels throughout. V cos theta, this is minus v by 2 cos theta. That becomes now v by 2 or v2 by 2 is equal to 3v cos theta by 2. That means velocity equal to 3v cos theta. So by applying momentum equation, remember we have taken momentum equation along horizontal. Okay. Now let us do one thing. We can solve same question. We can solve same question without using momentum conservation. See carefully once. It is now oblique projectile. We have learned one important point that motion of center of mass does not change because of internal forces. I am repeating, motion of center of mass does not change because of internal forces. So here explosion is because of internal forces. That means even after explosion, center of mass follows same parabolic path. Even after explosion, center of mass follows the same parabolic path. Okay. So here what happens is after explosion, one is retracing the path. It comes like this, retracing the path. Center of mass follows now. Center of mass follows the same parabolic path. No change in that. Center of mass follows same parabolic path. But coming to the second one, we can see it follows a path. It follows a path like this and lands somewhere here. Okay. Now what I am saying is, let us take point of projection as origin 0, comma 0. Then coordinates for center of mass r, comma 0. Now for this one coordinates, let us take x, comma 0. Okay. Now see what I can do here. xcm is equal to m1 v1. 1 is at origin. So it is m by 2 into 0. Okay. Next. Plus m by 2 into x, which we have to calculate upon total mass. So mass gets cancelled. x equal to this xcm is nothing but r, right? Landing at this position. So xcm is equal to 2r. Okay. This is now location of the second fragment. And see carefully. Because of velocity v cos theta, it covers a distance, or you can say displacement equal to r by 2 if velocity is v cos theta. See x value 2r, right? X value 2r means from here displacement how much? This is r by 2, right? This is r by 2. Remaining must be 3r by 2. I hope you are getting it. Up to here, distance r by 2. Remaining must be 3r by 2. And we are knowing that for v cos theta velocity, displacement is r by 2. Now to have displacement 3r by 2, velocity must be 3 times of v cos theta. Using this logic also, we can solve the problem. Means without using LCM. So this is by using LCM, this is without using that. Okay. Let us see next one. See the question carefully. Two particles A and B initially at rest move towards each other by mutual force of attraction. So key point is initially at rest. And why they are moving? Due to their mutual force of attraction. Okay. That means if we consider A and B as a system, this mutual force of attraction becomes internal force. Okay. Right. Next is the point. At the instant when the speed of A is v and the speed of B is 2v, the speed of center of mass of the system is. Just now we have discussed that because of internal forces, motion of center of mass does not change, right? Center of mass initially how much? Initially both particles were at rest, means VCM 0. And this becomes now internal force. Because of internal force, no change of motion of center of mass. Therefore, velocity of center of mass will be 0 only. Okay. Here you can see speed of A is v. Now do one thing here. Let us see carefully. Given A and B initially at rest. At one point of time, the velocity is v and 2v. Initially, both were at rest. So VCM how much means? VCM equal to 0. If you consider these two as system, then force by this on B, force by B on A becomes internal force, right? Means net force on the system 0. Net force 0 means ACM 0. ACM 0 means VCM constant. VCM is a constant. Now its value how much? 0. Therefore, it always maintains 0 only. That's why answer is 0. Okay. Suppose if they ask find ratio of their masses, then what I can do is MA into V should be balanced by MB into 2V because VCM 0 means momentum of the system is 0. See carefully, momentum of the system is equal to mass of the system into VCM. Since VCM 0, momentum of the system 0, its meaning is both having same magnitudes, directions opposite. So V gets cancelled. MA by MB equal to 2. Means if they ask, find ratio of their masses. Okay, let's see next one. An isolated particle of mass m is moving in horizontal plane along the x-axis at a certain height above the ground. It explodes suddenly into two fragments of masses m by 4 and 3m by 4. At an instant later, the smaller fragment is at y equal to plus 15 centimeter, smaller one. The larger fragment at this instant is. So again here we can take given m by 4, 3m by 4, smaller one plus 15. Let us consider first write down given data. It is given moving horizontally. Okay. Suppose x-axis. Now explodes. Smaller one is moving up. At one point of time, its position. It is given how much? It is given y equal to plus 15 centimeter, right? Like this. Now, second one, we have to find what is the y coordinate. Y1 and this is y2. Y2 how much? Again, we can focus here horizontally. Horizontally, there is no net force, right? But they are moving along vertical. They are moving along vertical. So can we apply momentum equation along vertical? Because Vertically, gravity is acting. Net force is not zero. Okay. But still we write LCM. LCM means law of conservation of momentum. See carefully. Net force equal to rate of change of momentum with respect to time. From this, what we can say? Change in momentum is equal to that F net into dt, right? Now here what I am saying is, if y is along vertical, okay, so you're having two possibilities. If you are taking xy plane is a horizontal, this logic is not required. Okay. If xy plane is horizontal, directly what we can say, horizontally there is no net force. So along y-axis also no net force. So we can take momentum conservation, right? So along x-axis it is moving means along y-axis for center of mass no velocity along y-axis. That means along y-axis, there is no shift in center of mass. Delta YCM should be zero. So what I am saying is if XY plane is horizontal, along y-axis VCM how much? Zero. Because moving only along x-axis. So delta YCM means shift in center of mass along y-axis should be zero. From this we can write M1 Y1 M1 M by 4 Y1 plus 15 plus M2 3M by 4 into Y2 equal to 0. M by 4 M by 4 gets cancelled. Remaining is now Y2. Y2 equal to Y2 equal to minus 5. That means it moves along negative axis. Okay. Now coming to this logic, suppose y-axis is along vertical. Then also we write momentum conservation. Reason is that in explosion time is very small. When explosion time is very small, so since dt very small, since dt very small, change in momentum is very small, which we can neglect. Then also we can write this equation. Okay. I hope you got the clarity. Let us go for next problem. Right. A body of mass 1 kg initially at rest explodes and breaks into three fragments of masses in the ratio 1 is to 1 is to 3. The two pieces of equal mass fly off perpendicular to each other with a speed of 30 meter per second each. What is the velocity of the heavier fragment? This is the question asked in 1981 for 3 marks. So 1 is to 1 is to 3. Total mass 1 kg. Initially at rest. Explodes. Explosion is because of internal forces, right? That means center of mass remains at rest only. That is the key point we are going to use in this problem. Next, two pieces of equal mass fly off perpendicular to each other, right? With a speed 30. Let us see how we start the problem. So first I'm writing here. According to LCM means law of conservation of momentum, initially center of mass was at rest. That means it is always at rest because explosion is due to internal forces. Next, given ratio 1 is to 1 is to 3. Right? Now, these two are moving mutually perpendicular. Let us take 1 is x and 1 is y. Then what I can write here? Mass is 1 by 5. Velocity 30. Suppose along x-axis. Next one, 1 by 5, 30 velocity along y-axis because mutually perpendicular. Coming to third one, I'm simply writing as V3 bar into its mass is 3 by 5. Okay. So throughout 5 gets cancelled, right? I can cancel 5 here. Remaining is now 3V3, right? 3V3 bar is equal to minus 30 into I cap plus J cap. 3 here 10 times. Remaining V3 bar is equal to minus 10 into I cap plus J cap. Now they're asking only speed, right? Modulus value. Modulus of that is given by 10 root 2 meter per second, right? So directly by using LC. Let's see next one. And this question also from previous IIT 1982 given for 2 marks. See carefully once. Three particles A, B and C of equal masses move with equal speeds V along the medians of an equilateral triangle as shown. Okay. They collide at the centroid of this triangle. After the collision, A comes to rest, B retraces its path with the speed V. What is velocity of C? Students, here the concept of collision is not required. Directly we can solve by using momentum conservation. Okay. See what is when equal masses, equal speeds. If you see carefully, this vector, this vector, and this vector, all three vectors having same magnitude because equal masses, equal speeds. And we can see they are now symmetric. Angle 120, 120, and 120. So by symmetry, resultant of these three vectors is 0. Okay. Having three vectors. And between any two vectors, angle is 120. And sum of those three vectors is 0. This is what we have learned in vectors, right? Now, after collision, A comes to rest. A comes to rest. B retraces its path. That means B moves from G to B like this, okay, in this way. And we have learned that net equal to 0. That means C must move opposite to B, means like this, in this way, with the same speed. So what is the answer? It is B. I hope you got clarity. A comes to rest, B retracing the path with a speed V. Since net momentum equal to 0, C must move opposite to B with the same speed. That's why answer is V. Okay. So very simple question. Let us see next one. A block of mass capital with a semicircular track of radius capital rests on a horizontal frictionless surface. A uniform cylinder of radius r and mass m is released from rest at the top point A as shown. The cylinder slips on the semicircular frictionless track. This is now diagram for that. Cylinder is now slipping, right? How far has the block moved when cylinder reaches bottom of the track? When cylinder reaches bottom of the track. How fast is a block moving when the cylinder reaches The bottom of the track, students, we can see carefully. If we consider cylinder and block as a system, on this system net force equal to 0. Means I am focusing only horizontally, not along vertical. Okay, because this is a smooth surface. If you are focusing horizontally on the system, net force is 0. Therefore, we can conserve momentum along horizontal. Okay. Next, here all surfaces are smooth. Therefore, we can write conservation of mechanical energy. Let us see. So we have to find how far block move, right? Block. And how fast is a block moving? Right. Given that this is smaller and this total one is capital, right? Okay. Now what we can say here, see how to start the problem. So we are taking the block. There is now one cylinder. Center is now exactly at this level, and this is given as capital R, right? Now see what happens. Since the surface given smooth, we can write, let us take a horizontal as x-axis. Okay. Now horizontally focus. First of all, VCM 0, right? Therefore, what I am saying here, along x-axis, there is no velocity for center of mass. Along x-axis. Region VCM 0, first of all, horizontally no net force acting. That's why VCM along x direction means along horizontal is 0. That means along x-axis there is no shift of center of mass. Along x-axis there is no shift of center of mass. Now see carefully. Displacement of a cylinder m into it moves when it comes to this bottommost point. Let us take let us take block moves by a distance x. Block moves by a distance x left side. Then I can write r minus r. This is now displacement of the cylinder with respect to cylinder. Okay, but in ground frame it will be minus x. Okay, plus m into minus x. So here what I am writing? I am writing here m1 delta x1 plus m2 delta x2 equal to 0. Okay, because delta xm is 0. So m1 delta x1 plus m2 delta x2 equal to 0. From this x equal to m into r minus r upon m plus m, right? This is now displacement of the block. Now we have to find velocity of the block. Okay. Let us take velocity of a cylinder, that is Vs. Velocity of block is Vb. If you take horizontally, momentum is a constant, means 0, right? So what I can write here, m into velocity of a cylinder should be equal to capital M into velocity of block. I am equating their magnitudes because net value is 0 and directions are opposite. This is equation 1. So we have two unknowns, right? So we require now two equations. So one more equation is, the next equation is energy equation. It is coming down by a distance. It comes down by a distance. See how much? mg r minus r. This is the loss in gravitational potential energy of the cylinder. This is loss in gravitational potential energy of the cylinder. This is converting into kinetic energy for both the cylinder and block. So I'm writing here half mass of a cylinder into Vs square plus half mass of the block into Vb square. Okay. Now what we can do here, we want velocity of block. So here what I can do is, I can replace mass of a cylinder. See from here, in the place of mass of a cylinder, sorry, velocity of a cylinder, I am writing here half small m in the place of Vs m Vb m Vb by small m whole square plus half m Vb square. Okay, that's the next one. I can take a half capital Vb square common, half capital Vb square common. Remaining is now, check it once, half m, sorry, half capital Vb square. Remaining is now capital M by small m, right? Check it once. One capital M I have taken outside, one small m and here gets cancelled. So capital M by small m, right? Plus 1. Okay. Now from this we can get directly Vb is equal to 2 mg r minus r 2 mg, and having here one more m, right? M upon capital M into m plus m, right? Whole power 1 by 2. Check once. 2 mg r minus r, 2 mg r minus r, small m I have taken there, by capital M into capital M plus small m. Okay. M and m square. You can take that okay, outside. That is not a problem. This is the final answer, right? So here we have taken one is along x-axis, we can write momentum equation. So that is what we have taken here. Their velocities are only along horizontal, right? So for cylinder velocity, only along horizontal at the bottom. Getting it? Momentum equation and energy equation. So two unknowns and two equations. Remain just calculating. Okay. So this is also previous IIT question. Right.